Hello everyone, welcome to my collection of wires and bits and pieces. I thought I'd do a quick video just to explain a tiny little project I've been working on. I have a dash cam in my car. I've recently replaced it, bought a new one, and it's made me realise that it doesn't shut down. So the power sockets, the cigarette lighter sockets in my car stay active all the time. Of course, I found this out the hard way when I went to start the car and the battery was flat. So yeah, a bit of a problem that the sockets stay live and I can't always remember to unplug the dash cam. So I thought of other ways. My car also has USB-C outputs which could directly power the dash cam, which is also USB-C, so I bought a long lead, tried that, but it turns out that the USB-C outputs on the car just don't provide enough current to drive the dash cam, so that didn't work. So I thought, well, I need something that ideally detects when the engine's running or not running. So that's what I've built. I've yet to test it in the car, but everything works on the bench here now, so no reason to believe it won't work in the car. I've obviously got to get rid of all the wiring and build it into a little box, but here it is in its functioning state. I'll go through the components first, and then I'll show you it working. So this little device here is a little Arduino board by Seed Studio. I think they call it the Xaio. Tiny little thing. Look how small it is. It is minute. Fantastic bit of kit. USB-C connection for updating it and writing the code to it, but I got it directly powered from a couple of solder pads on the back of it. So it's 5 volts into it. It's been powered by this little device, which is a buck regulator. So this will take voltage, DC voltage up to about 25 volts, and then you can adjust the output. So I've adjusted it to just below 5 volts. So whatever the voltage does on the input side, this will remain at 5 volts, so the Arduino stays powered. Then I've got a little OLED display. This part won't be here on the finished box because I'll just take this connector off and solder directly to the Arduino. So that's going to display battery voltage. Then we've got this little device. So this is a voltage divider. So we've got the car voltage here, so that will be sort of typically 12.5 volts up to about 14.5 volts potentially on the input side, and that reduces it down to a lower level that the Arduino can read on the output side. So we would typically, what am I getting on the output side? Probably somewhere between 2 and 3.5 volts, something like that on the voltage range on the output side. So this is directly wired into the Arduino as inputs, analog inputs, so I can read this voltage and then do a little bit of maths to convert it back to read what the actual voltage of the vehicle is and display it on this board here. Finally, we have a little 5 volt relay, which is also connected to the Arduino, but this time on outputs. So then based on what's going on with the voltages on the car side, we can make a decision of what to do with the relay. And the relay is then what will power the dash cam. So I'll interrupt the dash cam power directly through this relay. So let's show you it working. I've got my trusty bench power supply. It's a bit noisy, but so that's our current voltage output. I'll switch it on so we can see our buck regulator is now active, so that's feeding 5 volts to this Arduino. So that will be booted up. Only takes it, I don't know, maybe 2 seconds to boot up and start running, but there's no display active at the moment, and the relay is not active. It's got a little red LED on here. So neither of those are active at the moment, but that is because we're at 12.5 volts, which would be a typical sort of voltage as if the engine was not running. If I up it by 1 volt, we'll see what happens. So I'm going to do that, and you can watch the screen. There you go, 1 volt higher. You heard a click. Dash cam's turned on, and we've got a voltage reading 13.5553. Pretty close to the actual output, and to be honest, I don't know how accurate this is either, but it's close enough for what I need. So my thresholds, so that I've got a dead band as well, so I don't get to the point where if the voltage is slowly dropping, this all starts flip-flopping rapidly. I've got a dead band, okay, so between 2 values nothing happens at all. And those ranges are at the moment, anything above 13.3 volts will bring the screen on, bring the relay on, and then anything below 12.8 volts will then start some timers and eventually shut these 2 down. I can adjust those easy in a few seconds, so when I get to the point of testing it in the vehicle, I'll just make sure that those values are good enough for that vehicle and adjust it if I need to. So if I now reduce the voltage by 1 volt, we see that here we're now 12.5 volts. 12.5 volts. That's now running a timer. The dash cam is still active, so I thought it'd be nice to introduce a bit of a delay on it. So what will happen is after about 50 seconds or so, this relay will switch and the dash cam would be shut down. Watch that light. Should be any moment now, hopefully. Isn't this exciting TV? Isn't 50 seconds a long time when you're looking at it? I'm counting it. There we go. Okay, dash cam shut off. Now I've only got to wait about another 10 seconds or so. I added a little bit extra time on for the display. And just to go into a power saving mode, there we go, the display was shut down. And in that state, with it all still actively working and waiting to switch back on again, we're using 11 milliamps. 12 milliamps, 11, 12 milliamps. Okay, so about that, just over 10 milliamps. So we shouldn't really do much harm to the battery at all, not compared to a dash cam that claims it requires 3 amps at 5 volts. So that was draining the battery in about 2 or 3 days, whereas this shouldn't affect it at all. Yeah, so that's my little project. Here's the Arduino code for it. I'm using millis timers for the timings, and then everything else is just analog reads, libraries for the OLED screen, and then digital writes for the relay, and that's it. Nice, easy, job done. Just got to now build all this into as small a box as I can. I did buy a little enclosure. I was hoping to get it into this, but it's just not quite deep enough. So I'll find another enclosure, get rid of all the temporary wiring, solder everything up, and then hopefully test it in the car. So I might do a quick video to add on to the end of this with it actually working in the vehicle. Thanks for watching. Okay, put it into a box. It's not the ideal box, but it's what I had available. Plugged into 12 volt sockets there. Ignition is off at the moment. Turn ignition on. Now that shouldn't come on because the voltage will be obviously below 13.3. Dash cam is up here. I'm going to start the engine up. Engine started. Voltage appears. A little bit flickery on this. It's saying 12.76 at the moment. Dash camera's just powered up. Okay, alternator's obviously kicked in. 13.45, 13.4, 13.5, 13.6. Okay, so that's charging now. It's not flickering in real life, it's just the camera shutter. Switch the engine off. Voltage dropped to 12.7, 12.69. So after 50 seconds, camera should switch off, and then 10 seconds later, what's that rubbish down there? I need to have a hoover of my car. 10 seconds later the box is shut down. And only drawing a few milliamps to do it. Let's give this a wipe. Okay, waiting for the screen to shut down. Any second now. Okay, screen's gone. That's now reading just over 12 volts. 11.9, God, that was quite low. And the screen's gone. Probably need to go for a drive to charge the battery up. All working great. Excellent, happy days.